Hi, welcome to the review session. Am I on camera? I believe I am. I'm now going to walk off of the camera and get to the talk. And I'm back. I hope you all enjoyed that brief interruption. Stuff you should be able to do for the exam. Okay. You should be able to do power rule. That's binding derivative x to the n. The product rule. That's when you have two functions multiplied together. Remember, even if you have something as simple as x sine x, that's two functions, okay? So that would require the product rule to take the derivative. That's not one function, it's two functions. Quotient rule. That's f of x over g of x. That's the low d high minus high d low over low squared rule. Okay? Chain rule. Pretty much everything is the chain rule. Unless you just have x. Remember, if you have sine of 2x, chain rule. Because that's the cosine of 2x times 2. So we got quite a crowd for Palm Sunday. This is good. I was worried that I would pick a bad day. Okay, that's the chain rule. And then you need to be able to do implicit differentiation. Implicit differentiation. How will you know that you need to do implicit differentiation? You won't have y equals something, or f of x equals something. You'll have x's and y's mixed together in the problem. And you won't be able to just extract y. We have implicit differentiation because you can't turn the equation into y equals something. When you have the x's and y's mixed together, it's implicit differentiation. So if you have sine of xy, you would have to do implicit differentiation, and the xy would require the product rule. So we'll practice all of these in just a couple minutes. Okay? And then you need to be able to do the derivatives of, well, hang on, I'm going to write that somewhere else. Make a little table for everybody. Function, derivative. Okay. Your function is e to the x. What's the derivative? E to the x. What if it's not e to the x? What if it's a number other than e to the x, like b to the x? And then you do exactly like you would have done with e to the x, which is e to the x times natural log of b. Natural log of x, the derivative is 1 over x. And if it's a natural log, if it's a log other than natural log, log base b, 1 over x times 1 over the natural log of b. So if we gave you f of x is 7 to the x, then the derivative is 7 to the x, log 7. And if we gave you f of x as log base set of x, then the derivative would be 1 over x times 1 over log of 7. Okay, of course we can make this harder. Of course. All right, what's the derivative of sine? Cosine. Derivative of cosine? Negative sine. tangent is secant squared. The cotangent is negative cosecant squared. The derivative of secant. Sorry, that x kind of wandered down there. Okay. The derivative of secant is secant x tangent x. The derivative of cosecant, negative cosecant cotangent x. Okay. Then we have everybody's favorite, the inverse trig function. So arc sine of x is 1 over the square root of 1 minus x squared. And arc tan of x is 1 over 1 plus x squared. You don't have to worry about the other 4. Plenty of seats on that side. Go around. Although we're starting to fill up here. I should have been charging to pay my salary. Of course, then I might as well just charge you for the exam. You know, give you $10, you get an A, but that can't. Let's see. We're going to do that. You should be able to find the equation of a tangent line. You should be able to find where a function is increasing or decreasing. The way we set up the exam, okay, is about half the exam is just finding derivatives. If you can find the derivative, if you can do all of those, you will pass the exam. Okay? Then we're going to have some harder stuff on the exam. That will sort of separate out the A's and the B's. Okay? But if you can do all of the derivatives, you'll be in pretty good shape. If you're able to do all the derivatives, you'll be able to find a tangent line where things are increasing or decreasing. There's a couple of tougher problems. I don't think there's anything particularly tricky, but there's stuff to test if you really understand what's going on. Of course, I never really know what's going on, but sort of. So let's practice taking some derivatives. How about, well, let's pull some off of the sample exam. Yes? There's nothing about concavity. That's coming in the next exam, also known as the final. Yes? I suppose well, we can derive this class. If you watch the video. Again, that's what you're doing. So if you're doing the derivative of something to the x other than e to the x, what really happens is it's always times the natural log of base. But here it would be times the log of e, and log of e is just 1. You don't have to write it. Okay? Let's do some of those sample exams. See here. Sample. Sample. How about... Why don't I mean, I assume some of you guys have done some of this already, but I would say you should be able to do any of those 4 that's up there right now. Can everybody see that okay? I can play with the lights a bit. Is that better? No? I don't know how to do that. But I'm going to try. We might just be sitting in the dark for a few minutes. But let's see what happens. Better? No. How about this? No. Yes. That work? Okay. Sure. That should be entertaining in the video. Yeah, that's great. I don't know if you can see the board, but you can see that. But I'll put the lights back on in a minute, okay? So everybody make sure you can do that. Also, you know, they're on the webpage. So go ahead, take a minute. See if we can do those four. Okay, I copied them onto the blackboard so I can put the lights back now. Or not. This is fun. No? Oh. Well, I'm not a master electrician, that's for sure. All right, so I wrote them all on the board. Take a couple minutes.
Yeah.
One more minute. We're going to go through these. All right, let's start going through these. Some of you have already done these, of course. All right. So we have to do the quotient rule. So this is low be high minus high be low over low squared. So you do the bottom function times the derivative of the top function. What's the derivative of 1 plus 2x squared? 4x. Minus, other way around, 1 plus 2x squared times the derivative of the bottom, which is 4x cubed. All over the bottom square. So, how much do you have to simplify this? 0. Do not simplify it at all. That's asking for trouble. Okay? Ordinarily, you don't simplify anything. You only simplify if you have to do more. If you need more information than just to find the derivative. If you need to find where the derivative is 0, or if you need to find the second derivative, then you want to simplify it so when you do the next step, it's easier. Okay? But otherwise, that's good enough. All right? This one. This is product rule. So, sine of 2x. What's the derivative of cosine of x? Negative sine x. Plus, reverse, cosine x. And what's the derivative of sine of 2x? Cosine 2x times 2. Because we have a chain rule. And again, you're done. You don't have to do anything else with that. If we ask you to find the second derivative, okay, you'd have to use the product rule on this and the product rule on that. That's kind of cruel, so we wouldn't do that. Okay? All right. Yes. Now, you could write these in either order. You could put the minus sign in front. You could move the 2 to here or the 2 to there. It doesn't matter because you're multiplying. Okay? If you were to simplify this, you'd probably write minus sine x sine 2x plus 2 cosine x cosine 2x. That would be a slightly cleaned up version, but they're the same thing. Okay? Yes?
I have Professor Walden, and he said that we have to simplify on the exam, otherwise we'll get marks.
Well, Professor Walden, for those of you who didn't hear, we'll talk with all the professors, but remember the TAs do the grading, okay? And we will explain to the TAs that they do not need to simplify this, okay? You can raise your hand and say, Professor, that's not what the other professor said, and he and I get to fight. Okay. Can I take him? Big? Alright, I can be feisty. All right. Let's take a derivative. So remember, the derivative of arc tangent of x is 1 over 1 plus x squared. So this would be 1 over 1 plus this thing squared. Square root of 1 plus 3x squared. Times, chain rule, the derivative of the square root of 1 plus 3x, which is 1/2. 1 plus 3x to the minus a half times 3. Okay? Again, do you need to simplify it? No. One of the reasons we don't ask you to simplify is because, you know, if you mess up the algebra, then you get a lot of points off, but that's not really fair. The question is, can you take the derivative? Okay? Oh, here? You do it either order. The question was, could you do this either order? Yes, you can switch those two. It doesn't matter. Quotient rule matters, but product rule doesn't matter. Okay? Because A plus B is the same thing as B plus A, so the product rule is fine. Quotient rule, A minus B, is not the same as B minus A. Correct. You've got to do the low D high minus the high D low. Okay? You can always look at the pages I put up from my book. I explain it all. Then you can copy it. I would say you could buy the book, but why bother? I'm putting up the pages for free. Although it's $20, so you can buy the book if you want. Alright, the derivative of the natural log of tangent of x. Anytime you want to do the derivative of the natural log of a function, 2 steps. You write a fraction bar. You put the function on the bottom, you put the derivative on top. Just that straightforward, okay? Don't make it any harder than you need to. Okay? How do we do on those? Love and light? That's the kind of stuff you want to make sure you can do to pass. Okay? Should we do some more of these? These look a little harder. Ooh, that third one's kind of nasty. Let's see. All right. Do you want to do these again on your own first, or should I just start going through them? On your own? Do them as a team. Boy. All right. We'll do sort of a bit of both. So let's just do the first one. Everybody do it on their own for a minute. That is e to the sine squared of x. Let's say t, it doesn't matter. U to the 5th log u. Remember, the letter doesn't matter. Ooh. Everybody's finished? Need more time? Okay, I thought you might need more time. Yes? Oh, log sine of you. Thank you. Log of sine of u is not always defined. Because if sine of u is 0, you have a problem. Also, in natural logs, you generally should do absolute values because you don't take the log of a negative number. So, yeah. That would be you would have to, if you were actually working with the log of sine of u, you have to define the function more carefully. You have to say sine of u has to be between 0 and 1, not including 0. I know you guys don't lose sleep over that. But yeah.
Professor, what year test is this?
I don't know.
Okay.
This is
Okay, thanks.
fall 2009.
Okay, thank you.
You're welcome. Hey, Courtney. Yeah, it's fall 2009. It says exam 2-09-mod. I did that. Even your dress is yeah. Jump in the season. Okay. You can hang out with the other guy, sure. Who are you? Take it to the infirmary together. All right, let's start doing these. So this is sort of half as a team. We want to do the derivative of e to the sine squared of x. So e to the sine squared, we're going to need the chain rule. So first we do the derivative of the e part, which is just e to the sine squared of x. Okay? The e to the x is indestructible. It will show up everywhere through the derivative, okay? You can't get rid of it. So the derivative of the sine squared of x starts with e to the sine squared of x, and now you have to do times the derivative of the sine squared of x. The derivative of sine squared is 2, sine x to the 1, cosine x. Okay? Which if you're clever, you'll notice is sine of 2x. Yes? If it says minus cosine, it should say positive cosine in the solution, okay? There's probably mistakes. Some of the people who write these things up are just regular human beings. They haven't achieved the level of godlikeness that I have. You're waiting for me to make a mistake, I know. But if you do that, you set yourself up. Okay? All right, let's do the second one. Yes? You do not need to simplify that. You can leave it just the way it is. Okay, just the way you are. So Bruno Mars, Billy Joel, your choice. Okay? Derivative of u to the 5th, natural log of sine u. So, product rule. You can do it in either order. The u to the 5th, log of sine u. Log of sine u is you put sine u on the bottom, derivative of the sine on top. You could convert that to cotangent if you're in the mood. You certainly don't need to. Plus, reverse order. Derivative of u to the 5th is 5u to the 4th times the log of sine u. Okay? Question? Okay. So go back to this one for a minute. E to the sine squared x. Derivative of e to the sine squared x. Now to do the derivative of sine squared x, you have to do 2 times sine x to the 1 times the derivative of sine x, which is cosine x. The sine squared x is really sine of x squared. Okay? So you have to do chain rule on that. Okay? You should stop when you don't understand something. Okay. So here, u to the 5th. The derivative of the natural log of sine u is sine on the bottom, cosine on top. Plus, reverse order. Derivative of u to the 5th is 5u to the 4th. Log of the sine of u. Okay, now for the annoying one. So, the first thing is you could rewrite this as 1 plus x to the half, all to the half. Aha. Alright? So this is going to be some chain rule stuff. So first we do the derivative of the outside, which is 1/2 that whole inside to the minus a half, without doing anything to the inside. Times the derivative of the inside. Okay, so what's the derivative of the inside? Well, the derivative of 1 is just 0. And the derivative of 1 plus x to the half is 1 half. 1 plus x to the minus a half. Okay? Then you have to do the derivative of 1 plus x, but that's just 1, so you can stop. Okay. Go off on that one. This one. Okay. Go back to this. How do you do the derivative of the natural log of sine u? Derivative of the natural log of anything is function goes to the bottom, derivative goes on top. Sine on the bottom, cosine on the top. Okay? Come over here. It's chain rule with another chain rule on the inside. So first you do the derivative of the outside. That's 1 half. Leave it alone to the minus a half. Then times the derivative of this, which is 1 half. 1 plus x to the minus a half. Times the derivative of 1 plus x, which is just 1. Okay, so look worse than it was. Okay, last one. p dx of u dx minus pi squared. What's the derivative of u dx? And what's the derivative of pi squared? 0, are you sure? It's not 2 times pi to the 1? Okay, 0. Because pi squared is a constant. It's something. It's 10, 11, whatever it is. That's a perfect answer if you just write e to the x. Am I going to write down an explanation? No. Because I'm not going to be great? No. That's perfectly fine if you just write e to the x underneath. Okay? What if you had to do that? What if I said find the fifth derivative? 3x to the fifth. Very good. All right. So let's see what that does. The first derivative is 3 times 5x to the fourth. The second derivative is 3 times 5 times 4x cubed. I'm writing it this way for a reason. The third derivative is 3 times 5 times 4 times 3 x squared. You should be seeing a pattern at this point. The fourth derivative, I'm going to run out of space, is 3 times 5 times 4 times 3 times 2 x to the 1. And then the fifth derivative is 3 times 5 times 4 times 3 times 2 times 1 x to the 0, which is just 1. So notice this is 5 factorial. So you could write 3 times 5 factorial, or you could figure this out. So what's the sixth derivative? 0. What's the seventh derivative? 0. So if the derivative is any number derivative higher than the power, you're going to get 0. Okay? So I was asked when I was in calculus, what's the 100th derivative of x to the 99? They had calculus back then. Very primitive. You threw it in the wall of the cave, though, so at night it was very hard. Especially like if a dinosaur came in, and usually you're panicked in the middle of the exam. Okay? We had to find the 100th derivative of x to the 99, so you weren't going to find 99 factorial. That would take you the rest of your life. It's just 0. Okay? So if the number of the derivative is higher than the power, you get zeros. Okay? I remember when they invented calculus. No, I don't. They say it was on a Wednesday, but it wasn't. Not that old. Okay. You're going to get an A this time. Keep that up. Okay. That's what you're shooting for. All right. Let's see what else we've got on here. I don't like that one. That's a fun one. Okay. Wait. Let's practice with some more. And we should do 3 also. Okay, so when you do all of these, all right, the f of x is x natural log of 2x. What's the derivative? Take a minute. Yeah, hang in there, back around. All right, so the derivative is just the product rule. So it's an x. What's the derivative of natural log of 2x? It's 2 over 2x, also known as 1 over x. Right? Plus natural log of 2x times 1. Now this you would want to simplify because we're going to ask you for the second derivative. So this is 1 plus natural log of 2x. Yep. The chain rule is doing this. Okay? The question is why is there no chain rule for natural log of 2x? There is the chain rule. The chain rule is put the function in the bottom and the derivative on top. That's the chain rule. Okay? That's just a shortcut for natural logs. Okay? It's really 1 over 2x times 2. It's just a faster way of doing it. So now if you want to do the second derivative, well, the second derivative of the natural log of 2x, if the 1 goes away, you get just 2 over 2x, also known as 1 over x. And what do we ask? We say, where is it increasing, where is it decreasing? Oh, we don't care about the concatenative. So where is it increasing and where is this decreasing? So if you want to know where this is increasing or decreasing, you would have to take the first derivative and set it equal to 0. That's annoying. All right, let's solve that. Put the 1 on the other side. You get the log of 2x equals negative 1. And then exponentiate both sides. Do e to both sides. You get 2x. Do e to negative 1. What's e to the negative 1? That's 1 over e. Okay. 1 over e is whatever, 1 over e. And then divide by 2, you get 1 over 2e. Okay. So then the question is, where is this positive and where is it negative? Make a number line. You just have to figure out where is this going to be positive and where is it going to be negative. And it's tricky because you have e involved. So if you pick a number greater than 1 over 2e, like a half, how do I know a half is bigger? Because 2 is smaller than 2e. And then I get log of 1. Log of 1 is 0, so this is positive. It's increasing over here. And if you try a number less than 1 over 2e, you'll find it's negative. These things don't always alternate, but they usually alternate. Okay? Confused? Let's do that again. If you want to find where it's increasing or decreasing, you take the derivative and you set it equal to 0, and you get 1 over 2e. 2e is about 5.4, so you just need a number bigger than 1 over 5.4 and less than 1 over 5.4. You have to take a log of it. And you just need to find out if this log, if this derivative, is positive or negative. So I pick a half because I know that the natural log of a half is, that the log of 2 times a half, the log of 1 is 0. Okay? So if I let x be equal to a half, this is going to be 0. So a half is bigger than this number. Okay? So I'm going to get a positive value of the derivative when it's greater than a half. When it's greater than 1 over 2e, and I'm going to get a negative value when it's less than 1 over 2e. So if I said, where is this increasing? It's increasing on 1 over 2e, comma infinity, or you could write for x greater than 1 over 2e. I don't care if you use integral notation or not. Everybody quiet. All right. Okay. That wasn't a fun question, was it? No. You know, you're a Stony Brook. They work hard. All right. You ready for another one? Find where this ellipse intersects the x-axis. Because of course it's an ellipse. Okay, something intersects the x-axis where y is 0, and it intersects the y-axis where x is 0. Should I repeat that? You intersect the x-axis where y is 0, you intersect the y-axis where x is 0. So if we want to know where does this intersect the x-axis, just let y equals 0. You get x squared minus x times 0 plus 0 squared equals 16, or x squared equals 16. X is plus or minus 4. Okay? One more time. You intersect the x-axis when y is 0, and the y-axis when x is 0. Those are the intercepts, right? Puzzled? Good. All right. Find the slope of the tangent line at each of those points. Okay? So remember, these are the points 4, 0, and negative 4, 0. So now we have to do everybody's favorite implicit differentiation. Okay. What's the derivative of x squared? It's 2x. Minus, now for the derivative of xy, you need to use the product rule. Okay? So that's going to be x times the derivative of y, which is x times dy dx, plus y times the derivative of x, which is 1. Plus the derivative of y squared, which is 2y dy dx, equals 0. Okay? So remember, product rule. The derivative of xy, you need to do the product rule. You need to do x times the derivative of y plus y times the derivative of x. You love to use the product rule to test if you really know implicit differentiation. Okay? Now, you just say, find dy dx at these points. So you don't have to simplify this. You can say, at 4, 0, well, we'll get 4 for x and 0 for y. You get 8 minus 4 dy dx plus 0 plus 2 times 0 dy dx, that's the y, equals 0. now you just simplify that to 8 minus 4 dy dx equals 0, or dy dx equals 2. Yes? Good. Y is that x times dy dx? That's x times the derivative of y, which is dy dx. Y times the derivative of x, 1. Okay? It's not fun, folks. It's fun, or what do you call calculus? You call it fun. Okay. At negative 4, 0, we do the same thing, but now we're going to plug in negative 4. So you get negative 8 minus negative 4 dy dx plus 0 plus 0 dy dx equals 0. I think you also get 2 for that. Yep, you get dy dx is 2 again. I'll let you play with it. What? Sorry, okay. Where is the tangent line to the curve horizontal? That is, where is dy dx equal to 0? Okay, so now we're actually going to have to figure out what dy dx is. Go back to the original equation. Simplify it. You get 2x minus x dy dx minus y plus 2y dy dx equals 0. Okay. Group the dy dx terms on one side and non-dy dx terms on the other side. Factor out dy dx. And divide. You get 2x minus y over x minus 2y equals dy dx. So that's the first step. Okay? Now we want to find where the tangent line is horizontal. So know where the tangent line is horizontal. That's going to be where the derivative is 0. The derivative is 0 where the numerator is 0, provided the denominator is not also 0 there. Okay, so remember that. When you have a fraction, you have a rational expression, it's equal to 0 where the numerator is 0. Okay? So in this case, where is 2x minus y equal to 0? Where 2x equals y. So now you go to the original equation and you take y and replace it with 2x. Okay, so let's see, this is x squared minus 2x squared plus 4x squared equals 16. You get 3x squared equals 16. X squared is 16 thirds. X is plus or minus 4 over the square root of 3. That's the x coordinates. You have to plug back in to get the y coordinates. Well, the y coordinates are just 2 times the x coordinates. So you get 4 over the square root of 3 8 over the square root of 3. And negative 4 over the square root of 3. Negative 8 over the square root of 3. Okay? So again, in order to find where the tangent line is horizontal, you have to find the derivative, which is dy dx equals this, 2x minus y over x minus 2y, and find where that's 0. You take 2x minus y and you set it equals 0, you get 2x equals y. Now you take the 2x equals y and plug it into this equation. So where y is 2x, you take y and you replace it with 2x. Okay? So that gives you 2x times x, or 2x squared, and 2x squared is 4x squared. So then you can solve this, you get x is plus or minus 4 over the square root of 3, and since it's where y equals 2x, y is just double whatever x is. Okay? Yes? How do I get 2x minus y is 0? The derivative is this. 2x minus y over x minus 2y. A function is 0, a rational expression is 0 when the numerator is 0. So I have to take the numerator of this, 2x minus y, and set it equal to 0. Just that. Okay? I still see lots of confused faces. Take a minute, think about it. Or never. Yes? Okay, so remember, there's two answers. There's x is plus 4 over the square root of 3 and minus 4 over the square root of 3. Okay? And the points are where y equals 2x. So once I have the x value, y is just 2 times the x value. Okay? So if x is 4 over the square root of 3, y is 8 over the square root of 3. If x is negative 4 over the square root of 3, y is negative 8 over the square root of 3. Okay? This one wasn't fun. Okay, let's see what else we've got. Buzz, buzz. Nope. Nope. Okay. Here was a question a lot of people had trouble with. How do you do on number 2 in the homework? Terrible. Terrible. Let's go through it. Okay, this is not as bad as it looks. You just have to understand what we're asking for. Okay? You got the curve y equals x over x plus 1. The tangent line is going to go through point 1, comma 3. What does that mean? Well, first of all, you don't have to. If you could draw what y equals x over x plus 1 looks like, trust me when I tell you you get something that looks like that. Okay? Now, I go to point 1, comma 3, which is, oh, I don't know, there. Doesn't really matter. And I can draw the tangent line. Well, the tangent line is going to do that. It's going to hit the curve somewhere around there. And by the way, there's another tangent line. It's going to do that. It's going to hit the curve somewhere around there. It doesn't matter. We're going to figure it out when we do the algebra. Okay? So the tangent line is hitting the curve. So what we're asking for is basically, where does the tangent line hit the curve? Because if you do where it hits the curve, then you'll know how many lines there are. And there's something important to remember about tangent lines. Where tangent lines intersect the curve, you know two things. Because it intersects, you have the same x and y coordinates. The coordinate of the line is equal to the coordinate of the curve, whatever that coordinate, those coordinates are. The other thing you know is that the slopes are the same there. Okay? So I'm going to change this. I'm going to read through this in a second. Make it a little easier to see what's going on. points. Let's just deal with one tangent line for the moment. Okay, I have a tangent line, and it's going through the curve, and it's intersecting around there, and that's the point 1, 3. So we know that exactly this spot, the slope of the tangent line is the same as the slope of the curve. Okay? And they both go through this point. So what is that point? Well, let's give it a value. Let's say x equals a, and y equals, well, you want to call it b. Okay? But we know something about b. B is what you get when you plug a into the tangent line. It's also what you get when you plug a into the equation. So since this is y equals x, y equals x over x plus 1, this is the point a comma a over a plus 1. Okay? So the coordinates of that, how do I find that y coordinate? I just plug a into the equation. So far, so good? Puzzle faces are ready. So what do I do? I'm saying that the line intersects the curve at the point where x equals a. I don't know what a is yet. I'm going to figure it out. And when x equals a, y is a over a plus 1. All right, so what do I know? I know the slopes are the same. So what is the slope here? Well, slope is just difference in y's over difference in x's. So the slope is 3 minus a over a plus 1 over 1 minus a. I could write that in the other order, of course. It doesn't matter. Okay? But I also know, because I'm in calculus class, I can find the derivative, and that will also give me the slope. Then I can plug in a, and I can find an equation to solve this. So what's the derivative? Derivative. Well, low, d high, minus high, d low, over low squared, right? That's the derivative. Which simplifies into x plus 1 minus x equals 1 over x plus 1 squared. Okay? So remember, that gives you the slope of the tangent line. The derivative is the slope of the tangent line. So now if I plug in a, I should get the same slope. I should get 1 over a plus 1 squared. Okay? Now I can solve these by setting them equal to each other. It's a little annoying, but I can do it. So cross multiply, and you get 3 minus a over a plus 1 times a plus 1 squared equals 1 minus a. Okay? So that's annoying, but not so hard. So let's distribute that a plus 1 squared. You get 3 times a plus 1 squared minus a over a plus 1 times a plus 1 squared equals 1 minus a. You're like, oh my God, this keeps going. Okay? Well, these a plus 1's cancel. This a plus 1 cancels, and you get 3 times a plus 1 squared minus a times a plus 1 equals 1 minus a. So again, this is now just algebra. So once again, you found some point on the curve, a comma a over a plus 1, and you did the slope using the difference in the y's over the difference in the x's. And then you took the derivative and you plugged in a, you found the slope that way, and you're setting them equal to each other. So now the problem is that the algebra is annoying. So let's see. Boil out that a plus 1, you get a squared plus 2a plus 1. You pray that things are going to start canceling. Minus a squared minus a, watch your minus signs, equals 1 minus a. So you get 3a squared plus 6a plus 3 minus a squared minus a equals 1 minus a. We can cancel the minus a's.
Sure.
And you get 2a squared plus 6a plus 2 equals 0. That's not so bad. Divide by 2, you get a squared plus 3a plus 1 equals 0. And you get a is negative 3 plus or minus the square root 9 minus 4 over 2. 3, negative 3 plus or minus radical 5 over 2. You got that in your homework list. Good for you, okay? So that was hard. I'm going to give you an easier version of this in a minute. Okay? But I want to make sure you get the concept down. Okay? So those are your x coordinates. Where do they touch the curve? We won't ask you for the y coordinate. It's too much work to plug it back in. Okay? So do we understand the concept, which is the algebra that's annoying? Now let's do one with less annoying algebra. Okay. Okay, so you have the curve, f of x equals x squared plus 4. Where does the tangent line through 8, 0 intersect the curve? Okay, so this is the same concept, it's just going to be much easier algebra. Okay? Take a minute or two and let's see if you can do this. I think you need at least 1 minute. Okay. Let H pop up. Let H pop up. Okay. You got married. Five years from now, I'm going to ask you the same question. Remember. We're going to look at the top. There you go. Okay. How's it better? Better video. I got the good things. We had some All right, how are we doing on this one? Are we done? Need another minute? You get it? Waiting for me. I'll give you one more minute. All right, that means we're ready. So we have the curve. F of x equals x squared plus 4. Looks something like that. And we've got a tangent line, oh, I don't know. And that's 8, 0. Okay? So it's going to intersect at some place where x equals a and y equals a squared plus 4. And now you've got to find the slope. Well, the slope is difference in y's, a squared plus 4 minus 0, over difference in x's, a minus 8. Okay? But we also could find a derivative. I know that f prime of x is 2x. So f prime at a is just 2a. So this has to equal 2a. How do we do on that? So far, so good? So if you get to there, you've already set it up nicely. Now you just have to execute this. So a squared plus 4 is 2a squared minus 16a. And that solves to whatever it is. A squared minus 16a minus 4 is 0. And, you know, I made it up off the top of my head, so the number doesn't come out so good. You get A is 16, plus or minus the square root of 256, plus 16, over 2, whatever, square root of 272, 2, that simplifies over here. So this tells you, by the way, that there's actually two places. There's another one about there. Okay? Got the idea? So the only thing that was maybe barred in the homework was just a tougher equation. Were there other paper homeworks that were tough? Let's see. Don't have to worry about that one. How about some web assigns? And? I'm sorry? Oh. Well, let's see. See how nicely you can get into WebAssign if you don't use Safari?
Ooh, that was fun.
Oh yeah, there was that one. How do you do on number 22 there on the weather song? Should we go through that one? What? Sure. Alright, so we don't want to do the weather signs. I'll just make up a few more problems for everybody. I won't keep you here too much longer. I want to make sure you're good. Let's see if you can find the derivative of that. That looks annoying. Now we can test everybody. For you. There you go. Now let's take the derivative. 1/2 inside minus 1/2. So the inside is sine of x to the third. Now we have to do the derivative of sine of x to the third. That's cosine of x to the third. And then we have to do the derivative of x to the third, which is 1/3 x to the negative 2/3. Okay? How do we do? Good? We all do that one? It's going to make me very happy. Alright, let's see if we can come up with something harder. It's actually what's called a hyperbolic function. Yes.
Are you sure that's what it is?
Write it down and go next to it. As long as you don't have a lot of pressure, right? That's cosine. Negative cosine squared. How do you know how to have a lot of Really? Yeah, but hyperbolic. But hyperbolic. Those are the functions of imaginary. Oh yes. Generally they'll cover. Yes, that's why I do it. You asked. What? Yeah, okay. You asked. You get something like this. There it is. Oh, it's exactly that one. See, great minds think alike. These simplify a lot. Now, you don't have to simplify them, but they do. So if we ask for the second derivative, you would want to simplify it. But dy dx is low. E high. All right. What's the derivative of this? It's e to the x minus e to the minus x times minus 1. Times minus 1 just makes it plus. Okay? Minus, other way around, e to the x minus e to the minus x times the derivative at the bottom, which is e to the x, plus e to the minus x times negative 1, which is minus e to the minus x, all over e to the x plus e to the minus x squared. So remember with the chain rule, since the derivative of e to the x is e to the x, the derivative of e to the minus x is minus e to the minus x. Okay? So here, let's take a couple more off the sample exam. Oh, here's something we haven't done yet. We haven't done any logarithmic differentiation. What if we had to find the derivative of that? Why do I call it this problem? Can we do this one? This is logarithmic differentiation. How do we know? We have a function raised to a function. Okay, remember what you have to do? You have to take the log of both sides. Okay? And then do the whole derivative. No, we don't remember that? We did that just the other day. Slow me down. Right, natural log of both sides. Do that step first. And do a little differentiation stuff. Remember, I did x to the x. I did x to the sine x. Remember, your first step is going to take the log of both sides. So you can do that before you do anything else, okay? And you do some derivative stuff. You're in calculus class. And they keep emphasizing, you're in calculus, so you just take derivatives. Product rule plus chain rule. There's chain rule everywhere. Here is not really a chain rule. Barely a chain rule. Alright, so you want to take the derivative of this. You get 1 over y, dy dx, equals, now you need the product rule. So it's tangent of x times the derivative of the log of x plus 2, which is 1 over x plus 2, plus ln of x plus 2, log of x plus 2, times the derivative of tangent, which is secant squared x. Okay. Now, multiply through by y. So dy dx is y times tan x over x plus 2 plus log of x plus 2 secant squared x. And now, replace y with what it was originally. Okay? Everybody got that? How did we do on that one? Should we do another one? That's it. Should we do another one of those? We got the concept. Another one? See, one hand. That's it. Yes? One more. I'll do one more of these. That was fun. Find the derivative of that. So, first you take the natural log of both sides, the log of y, the log of sine x to the x squared plus 4, and then use the log rules to bring the x squared plus 4 in front. Okay? So just like the last one, we just now have a messy product rule. Pretty much what you're always going to have. So you get 1 over y, dy dx, equals x squared plus 4. Now what's the derivative of the log of sine of x? Sine x on the bottom, cosine x on top. Also known as cotangent. Plus log of sine x times 2x. Okay? Now you just have to rearrange this. So you multiply 2 by y. X squared plus 4 cotangent x plus 2x sine x. And then replace y with its original function, which is sine x dx squared plus 4 times x squared plus 4 cotangent x plus 2x sine x. Okay? Yes? How will we know we need to use logarithmic differentiation? Be very simple. You'll see a function of x. It'll be raised to a function of x. Okay? It won't be raised to a number. It'll be raised to another function. So you have a function on the bottom and a function on top. Okay? And that's how you'll know you need to do logarithmic differentiation. You can use it for other things as well, but this is the main one that we're going to ask you to be able to do. Okay? All right, I think that's enough for a Sunday. So, we'll see you guys later.